We have Subhadeep, Mukesh, and Ashish presenting Yoda, helping customers find the right answers. Let's hear it for them, guys.
Hello, everybody. Am I audible? Okay, good. So I am Mukesh, and I'll be speaking about a product Yoda which we have developed, which is used to help customers find correct answers in real time. Okay. So let me ask you a question. How many of you have done shopping on Flipkart? Okay, that's pretty good. So did you face any problem after placing the order? When you have to contact to our customer care center? Okay. So what kind of problem is that? Okay, got it. Any other query? Okay. So you wanted a different color product. Okay, okay, good. So let me tell you my story. So the during Big Billion Days, I ordered a phone which had cashback offer on credit card. I received the phone next day, but I did not receive cashback. After some time, I was curious that why I did not receive, so I called customer care center and asked them. They told me that, sir, you will receive it in 45 days. So now the question is, how did they know that I will receive it in 45 days? And this information was not available on website, by the way. Okay, so let's move on to another story. So that same phone developed some problem. So after some time, while charging, it was heating up. So I thought that I will return this phone. So I called again to customer care center, and they told me that, sir, you can return. There are set of steps. If you follow, if the problem is resolved, then it's good. Surprisingly, the problem was resolved. The third problem is most of us have multiple addresses in our account. So while placing the order, sometimes you choose a different address. And just after placing the order, you realize that I have to change the address. So the quickest way could be just go to help center page and search for how to change the address. Then you get the answer. So with these three type of problems, I'll be discussing like how we are solving this. So let's have a look at CX at Flipkart. So CX is like we have a very big customer care center, which is spread across different cities. There are many issue types which executives are solving, and they have to solve it in real time and for all kind of queries. So as for example, so the phone developed problem. So there are n number of phones which Flipkart sells, and there could be different problems for all the mobile phones. So how are they able to troubleshoot? So that's the question mark. So how we are solving this problem is with data. So what kind of data we have? So the entire presentation will be around, first line is like we will be defining the data types. The second line is data pre-processing, and third is query pre-processing, and fourth is search. So let's have a look at the kind of data. So we have article. Article is nothing but HTML, a big HTML page where there are, so it will be talking about a particular topic, and within that there will be many subtopics. So I'll go in detail about this. Guide is again the troubleshooting guide which I described before. So here guide is structured as a tree, and at different nodes there are decisions which depending upon your problem is taken, and next path will be followed. So third one is FAQ. FAQ is nothing but question answer. It's very simple. The address change problem is related to this. And then we'll be talking about how we are decomposing the data. Like article could be very big, but we don't want to present a big article to our executives. So we'll go in detail. Then how we are tagging it. So tagging, I'll define it in later on. Then we have issue prediction. So what are issues and how we are predicting the issue from the data. And then final two is query pre-processing or processing and search. So let's move on to the knowledge base article. So KB is knowledge base. So article is, as I talked about, that it is HTML. So it could be huge. There is very little structure in this. So now the problem here is our customer care executives are solving problem in real time. So when you called, then you would want immediately the answer, right? So they have very little time to get the knowledge. So we have to present the most relevant information to them. So articles typically talks about these 4 things: product launch, some offer launch, so which describes the offer in detail, as you see on website, but I think we hardly read about offers in detail, right? And then there are communication guidelines and some process changes. If they have any process change for them, like one could be return process or refund process or replacement. The second type of data we have is troubleshooting guide. Like I said that this is inherently a tree structure. So how we have organized the data is, so typically it starts with a category or brand. Below that there will be product name, because every product might have different troubleshooting steps. So these we call entity nodes, which are basically product names, or it could be attributes also. Then we have issue types, which describe the issue related to that product. So I'll go with only one path because it will be a very big tree. So I have just listed some of the paths. So this there is the issue is battery, and then we have sub issue battery heating. It could be also battery not charging. The third node type is troubleshooting node, which describes the steps. Like if this is the issue, then how will you resolve? So there are set of steps. It could go up to any depth. So there are decisions at each node, and then it will move to the subsequent node. The third data type, which will be talked later, is FAQ, which is just question and answer, which mostly the general knowledge part of Flipkart ecosystem. Okay, so now let's move on to pre-processing. So how are we massaging the data? As I talked about, that articles are very big, and we don't want to flood lot of data to our customer care executives. So how we do this is, from HTML, there is a library JSoup. Using that, we flatten the data. So HTML is also a tree structure. So we flatten the data like this, that nodes and its depth. So we got a list of nodes and depth. D is depth, by the way. And this is the node representation. Then we do the grouping based on some logic, like we try to learn that on what basis author might have decided to write the different sections. So it could be a strong tag, it could be H tags. So we first analyze the data like what they have written, because HTML can be written in multiple ways. So that is the grouping part. The third part is filter and merge. So filter is like if we want to remove some of the tags. Like there was a arbitrary tag like SUP. So we wanted to remove that. It did not have any data. And then we merge some of the siblings or their children, depending upon some logic. So we have applied there. Then we do a balancing, and balancing is like, again, if the section is coming out to be very shorter, like 1 or 2 keyword, then we try to combine with previous or next section. And then we do a fuzzy match of each section, so that if 2 sections are coming out to be duplicate or nearly equal, then we remove one of them. So now we are left with smaller sections for the article, which is used to present as a search result to executives. Okay. Now let's move on to tagging. So what is tagging? Tagging is extracting important keywords from the data. So why we are doing this? Because we want to be more relevant towards our results. So let's look at this sentence. Samsung Galaxy S7 display not working. So how our tagging works here is we want to classify the brand, product or attributes. So we have defined some of the context. I'll talk about that later on. So here the brand, Samsung is tagged with brand with probability 1, which is like it's an exact brand. Similarly, product and attribute. So in the second example, here we have just specified iPhone, but since iPhone is not a product, so there is some probability with 0.72 it can match with iPhone 6s or 6 or iPhone 5 maybe. Why tagging is required? Because we have 2 types of search. One is contextual search. Contextual search is like whenever your call comes or through any channel, like if you have written an email. So related to one of the order. So we get some context from order. So let's have a look at what kind of context we have. So it could be brand, like which brand product you have ordered. So it could be one of these, product name, product attributes. So in case of mobiles, attributes also matter because some of the mobiles are, like many of the mobiles have Android. So if there is problem related to Android, then we can directly land up to that node. Then other context could be bank, payment method, etc. So this is the data which we will be tagging with, right? So what is the simplest method for tagging? Can anybody tell me quickly?
Matching the keywords from a dictionary of keywords.
Okay, that's pretty good. So the simplest method could be just a string match where you have a dictionary again and you do the substring and match it. But the problem is that it's pretty inaccurate and also expensive on performance. So let's move on to other methods, which actually we have tried two methods. So I will discuss about those two methods, pros and cons. So the second method could be extracting phrases. So the benefits here is that you don't have to maintain a dictionary because while maintaining dictionary, you have to insert data and remove also, right? So here we have used a library developed by University of Arizona. So that library is based on Stanford NLP. So it provides two things. One is POS tags, one is BIO encoding. So BIO is nothing but begin, inside and outside. So given a text, so like in case of Samsung S7 display not working. So it will tag each of the keyword with POS plus BIO. So we have defined some logic. Based on that, we detected that whether this is a phrase or not. So it works really well, but did not fit our use case because phrases comes with like, there are a lot of keywords which will come with phrases, but we wanted to be exact match. So let's move on to another technique. This is a KIA. KIA is nothing but keyword extraction algorithm. So in KIA, the most difficult part was training. So training data, they had to be put in particular format, which was difficult to generate. And also since we had sparse data, so it did not work well. So let's move on to our approach. So we decided to maintain a dictionary because with dictionary, you exactly know what is your data. And it will be pretty accurate if we go ahead with our dictionary data. So we collected all the dictionary like product names, brands, attributes and all. The second is, there are two types of data here. I wanted to make it clear here because it will be very difficult to understand. So one is the dictionary data, one is the incoming data. So dictionary data is used to tag incoming data. So here we are talking about dictionary data. So for each of the data, we generated n-grams, put it in some of the indexing, maybe Elasticsearch. And then for incoming text, we also do the n-gram from 2 to 8. I will describe with example and match there. And after matching, do some fuzziness and check, re-rank the results. So again, the implementation is with Elasticsearch and Fuzzy Wuzzy. Fuzzy Wuzzy is a library to compute if two strings are similar or not, or how much similar. So this is how we have implemented in Elasticsearch. So we have defined set of filters. So on the left-hand side, the first one is tagging single filter, that is our name. The type is single. Single is again a filter provided by Elasticsearch, which will make your keywords as a token. So even if it's 2 gram or 3 gram or 4 gram, it will become as a token. So it's very good for exact match. So we have defined minimum single size as 2 and maximum as 8 because we wanted, and this also takes unigrams because output unigram is true. The second filter is very simple, English stop words, which will remove all the stop words from the data. The third one is possessive stemmer, which is, it will remove apostrophe s. And the last one is light stemmer, which is very fast. It's K-stem based algorithm. And this is the analyzer. So analyzer, in the analyzer, we specify all the filters which has to be applied in a particular series. Like here we have given 5 filters here. So in this method, you have to create a mapping for each of the dictionary type. Like for product name, for brand, for, and you have to put these fields there. So one important thing here is that we are using highlighter, which is FVH, fast vector highlighter, and analyzer we have specified. So let's look at the example. So this is the dictionary data, Genphone 2 Laser 550. So this is how it will generate the singles. So first unigrams. Unigram is single keyword, bigram is 2, by the way. So Genphone 2, all the combination it will generate. So the benefit of this is, even if the incoming text is Genphone, then there is a chance to match this with this product. But the probability will be very low. So that logic is with us, like how we want to take. So let's go ahead with the example. Samsung Galaxy S7 display not working. This is the incoming text. So whatever we have done till now is the dictionary part. So this is the text which we want to get it tagged. So again, the steps are like we will generate all the n grams from 2 to 8. So I have, in this example, it's only 2 grams. And we will fire a set of queries for each set of n grams, like for 2 grams, 3 grams, 4 grams. So this is how we get result from Elastic. Samsung S7, that is highlighting EM. So the first one is S7 Edge, that is a product, but it is a partial match. And how it is able to do a partial match? Because this will be captured as a single in 2 gram when we had inserted the dictionary data. So these are the 3 results. Now we have calculated the fuzziness score. Fuzziness score is between highlight part and the actual data. So actual product name here is Galaxy S7 Edge. So we will calculate fuzziness score of Galaxy S7 and Galaxy S7 Edge. So that is coming out to be 78, and then the second one is 29, because inside there is a very small part which is matching, and third one is 100. So now it's up to us that what will be the cutoff. So let's say the cutoff is 75, then first and third one will be selected, will be tagged here. Okay, and then we do the re-ranking. So the best part with this technique is that we were able to tag 5,000 nodes in less than 50 seconds. That's pretty good, because considering the number of queries we are firing and the kind of computations we are doing. So now I'll invite Subhadeep to talk further. Thank you.
Yeah, hi everyone. So let's move forward. Let's look at some of the other search techniques we have been working on. So one of the key things which Mukesh mentioned is that our customer support agents are actually dealing with a lot of issues. So what we actually need to do is to figure out what is the potential issue for a communication which is happening with the customer support center. So typical way in which such a communication can lead to an issue is you send out an email or you choose an option on an IVR saying that I want to do a return approval. My return is not getting approved. I want a return approval. So identifying issues inside an article, which is let's say a knowledge base article we have, is actually pretty useful, because we can show to a customer support agent that this is related to return approval. Let's fire up these set of documents which might be relevant in this case. So what is the key challenge over here? The key challenge is that the text we have as documents vary in length severely. So we have documents which are 3-4 lines. We have documents which are pretty long, which span over pages. And there are multiple issues which are spanned by a single document. So you can have a document which talks about return approval as well as refund. Because, I mean, in real world, things are related, right? I mean, you just can't just say that this is related to X. So, so that I explained that why you need to do this. Yeah, so let's look at the technique which will be very useful here. So the name is NBSVM. So the technique is called NBSVM, which is naive-based support vector machine. So as I mentioned that the documents vary largely in size. So from literature we know that generative models like naive-based do not work well on short documents, while discriminative do not generally work well on short ones. So what you need to do is to come up with a robust algorithm which can address both these problems. So one of the key developments in this area was done by Christopher Manning, which I'm sure many of us are aware here, which is a naive-based support vector machine. The key idea is actually extremely simple and easy to implement. What you do is you take a naive-based vector, which is just a fancy way of saying that you want to count the occurrences of a token across class. Let's say you have 3 classes. You have 2 classes. Let's take an example, spam and ham. You want to count that how many words which you saw in the training data come from this and come from that. So what you do is you append the naive Bayes vector with the support vector machine. Yeah, so another thing which helps us to improve accuracy in this case is actually appending an embedding vector with the naive Bayes vector. What that means is word embedding is actually a technique which allows you to get semantically close things together. Let me give an example. Let's say you have news articles. You have a data set of news articles. You see that there is a word called Barack, there is a word called Obama. But in news, we see that Barack and Obama generally appear together, right? So that allows the embedding algorithm to compute that Barack and Obama are pretty close to each other. We will see how that is useful further along the line in this talk also. But for here, what we see is that if we append the embedding vector with the naive Bayes vector and allow a averaging of word using a TF-IDF kind of a scheme, which is just another way of saying that how important is this token with respect to this document. That allows, that gives us a pretty reasonable boost in accuracy. So let's talk about what is the sort of accuracy we are getting. So if I go over this, so we see that the data set is actually a 80K outbound email set. And what we observed is that you get a very good F1 score of 0.82, which is just a formula of which combines precision and recall together. So what we saw is that we get a good precision recall on major issue types, which allows us to classify documents extremely well. Yeah, so let's talk about some of the other things here. So troubleshooting search is what? Gaurav, I'll invite Gaurav to cover.
Thanks, Subhadeep. Okay, so that's a lot of context that has been generated by Subhadeep and Mukesh. I can see it on your faces. Let's come to something lighter. So how are we using the context? I'm going to talk about that in our search. So the first question that comes to anybody's mind, okay, fine, we are providing a search on troubleshooting guides. So what are we going to show our customer care executive who are on call with a customer, resolving a customer issue? Our main aim is to minimize that time, the time of resolution our agent is going to take. How we do that? Using a search on troubleshooting guide. What are we going to show them? Show them entire tree, show them how to show them a subtree, show them the root node of a tree. What is it that we show them? If we show them a proper subtree, it's going to take them a little time to traverse through the nodes and issues to arrive at a particular node or desired node. So what you're going to show them is a proper node. And how we're going to show them using context-based search is what I'm going to talk about here. And there's another text-based search which we'll see in further slides. So this is a sample guide. So how the context flows is top to bottom from the root node of a guide and to the leaf node. So as Mukesh told earlier, the first node is usually the category node. As you can see, it's a Motorola mobiles. From that, we can get a context that the brand is Motorola that we tag with the root node of the guide. Then you come down further. From here, we can clearly get a very good context. The product name is going to be Moto X Play. Fine. We add it to the tagging data structure that we have. We associate with that to a particular node. And then we come further down. That's the issue, the camera issue for the Moto X Play. Now, what you're going to do, put the issue as camera, associate that with the camera node, and we keep doing that till we reach the root of a node. Okay? Sorry, the leaf of a node. So this is how a context is built. And now, let's say a query comes to us, which is an issue related to a battery or camera or whatever. We have an issue with us, we have a product name with us, we have a category with us. It's very easy for us to match the query with the desired content we have because that's how we are generating our content. How do we do that? It's very easy. We have Elasticsearch templates to do that. To get a context-based search and a text-based search, we're using one single template for both. We have 2 partitions in our single template, one for context-based search and one for the text-based search. Obviously, the score is a little higher for the context-based search because we have exact matches there, exact product match, exact category match, exact issue match. So the score is going to be obviously higher. And for the text-based search, the score for that section in our template is lower because there's a fuzzy match as well, because we're matching on the title of the node, the content of the node as well. So that's what we do. So an easy Elasticsearch-based solution was enough in this case. But in certain situations, a simple Elastic-based search is not a the final solution that you're going to get. And we will talk about it in further slides. And this is how it feels when you land into an exact node. Further, I will ask Subhadeep to talk about another content type, which is FAQ. Subhadeep.
Yeah, thanks, Gaurav. So
Thank you.
let's talk a bit more about some of the customer-facing products we do have. So what all we talked about is actually agent-facing, as in troubleshooting guides and articles are agent-facing. So what are FAQs? So FAQs are actually short documents, as Mukesh mentioned. So one question comes to mind is that why do we need them? What we observe is that Flipkart customer base varies a lot in its demographics. Sorry about that. So you have different customers coming from second and third tier cities, and on top of that, we have a lot of new customers who join us every day. So simple commonplace knowledge like how do I change my delivery address or how do I place an order, which is extremely simple for all of us, might not be simple for them. So FAQs are actually a repository of all such documents which allow us to answer these questions well. So what is the benefit we get? The benefit we get is it helps a lot in reducing the customer contacts. This is something which we have observed once we build the product. So let's talk about how do you do search on that, right? Because that is the theme here. So the major question is that given a short query, how do you actually retrieve a relevant FAQ, right? So what are the key challenges here? So once again, as is the recurring theme, that documents are extremely short, and on top of that, you have the number of documents being small. So being a small set with small documents, it introduces a lot of challenge that you have to get a good relevance in terms of the questions. Yeah, so let's see what is the solution which comes to mind when you have a search problem, right? So you'll say that I will Elasticsearch that, right? So let's talk about why that will not work, right? So let's say that the query is product exchange, right? So as you can see that there is not even a single document in our data set which talks about product and exchange together, right? So how do you solve that, right? Let's say that you want to still retrieve an article which is how can I return or exchange an item? What items can I exchange? How do we do that, right? So one of the key techniques which we worked on is concept linking, which is just a fancy way of saying that you tokenize your document not into word, but instead into concepts, where concepts are defined as noun phrase chunks. And what you go ahead and do is define a linkage between the concepts. So we'll talk about that using an example and we'll backtrack. So let's say that there is a document, what is cash on delivery, follows with the rest of the explanation. And you have a query which is delivery is delayed, right? So as you can see that this document is actually a very bad match for a query like delivery is delayed. But the point is, how do you stop this from coming? Because this is a single token which matches very strongly. So what you could do is, you can compute a penalty between the concepts which are present in this document. What are the noun phrases which are present? The noun phrases are cash on delivery. So if we had a technique which allows us to compute that cash and delivery are two separate concepts, but they are not related much, that allows you to compute that you should penalize this document if one of the concepts is not present in the query. So that is how, if you query with delivery is delayed, you are not supposed to get what is cash on delivery. Now let's see that how that can be done. So so let's talk about that. So what you do is that you tokenize the document set into chunks of noun phrases, and you learn a word embedding model which allows you to compute that what is the distance between the two concepts which are present, right? So on top of that, what we could also do is query document distance, which is just again a way of saying that you represent a document as a tokenized set of concepts which you present onto an embedding space, and you define a weighting scheme which is again TF-IDF. And what you can do, what we implemented is that you can use locally sensitive hashing, which is just a way of computing approximate nearest neighbors, right? So what is the overall algorithm? Someone might be interested. So the overall algorithm is Elasticsearch query. There is no denying that Elasticsearch is useful. And then on top of that, you have concept linkage penalty. and on top of that, you represent all your documents onto a embedded space, right? So now let's talk about a bit more on augmentation techniques which we do, right? So let's say that, let's take an example that you have a query like return product, right? So what we do is we expand the query with return product item policy replacement, which allows us to improve recall. Why do we do that? The reason for doing it is that our data set is extremely sparse. As I mentioned, that the number of documents is small. So you cannot actually effectively get a document for return product. Reason being, product and return separately are very strong, let me put it that way, that very strong Lucene keywords. So they have a strong appearance in multiple documents. So if you just do a plain query, you will get a bunch of results with return, you will get a bunch of results with product, and then you will rely on your CTR to fix that. So that is one of the obvious solutions. But what another challenge we have is that the usage will take, so you have the classic cold start problem that you do not have the usage to begin with. So this allows us to solve that problem well. Right, so once again, how do you do that? Very simple, word embedding, recurring theme here. So you learn, in this case, you learn a joint embedding model on document as well as queries, which is there. And what you do is you model the queries onto the embedding space. Now, one key question here is that how do we define the weights for the query term, which I will skip because that will take a while. Let's go over the rest of the algorithm, that once you have an optimal set of weights defined, what do you do with that? So essentially what you see here, the problem is of computing the distance between two bags. So what do we mean by bags here? Bags are actually, there is a query bag you have, there is a document bag. Both are represented into concept space. So what you need to do is to compute the distance between the query bag and the document bag. So one of the standard formulations for solving the problem in literature is a integer linear programming problem, which is a earth mover distance, which is just a fancy way of saying that you have a bunch of mud pits, you have a bunch of holes, and there is a cost associated for moving some one hole's mud to one pit. The problem is, how do you define, how do you figure out that what is the least cost? So one key thing here is that computing EMD for a large data set is extremely inefficient. So a bunch of guys published a paper in ICML which allows us to compute a tight lower bound. So we just went ahead and implemented the paper that allows us to compute document and query distances pretty well. So let's talk about enough of theory. Let's talk about some of the examples. So let's say that the query is order EMI. So what you do is that what you get is some of the expansions are payment, amount, and place. So if you like ponder over a bit, you will be able to see that order is somehow closer to place, while EMI is closer to amount and payment. So that is sort of the pattern which comes out from the data. Again, another good example is product and ship. We all know that seller ships a product, right? So that allows us to compute this. So there are a bunch of examples which we can go over. So yeah, so what are the key learnings? For that, I will invite Mukesh on stage to share with us.
Yeah, so so the key learning here is that we don't have big data, but we have small data. So small data also comes with a bigger problem. Like it does not represent like different entities the way we wanted, the relations which we had to dig into. The word embedding models was not sufficient. So we had to tweak that and also jointly embed that with the queries. So that is one problem. And the another thing is like the trivial solutions which are present or the papers which we implement is not the like solution to everything. So we have to do some POC and see if the things are fitting in our case or not. Okay, so let's have questions. So we have a program here which is for best question we will be presenting coffee mugs. So please go ahead and ask a lot of questions. Okay. Yeah.
So let's say the customer is not clear about the issue.
Okay.
For example, I purchased the phone on Flipkart and I say the phone is getting restarted automatically while in my pocket.
Mm-hmm.
So I tell this to customer care.
Okay.
So how this
Yeah, sure. So uh, there must be an order, which is a phone, right? So as soon as you call to our system, then we know, yeah, we know that from this order number, this phone, this brand, and this all data we have, right? So we generate a context from that. So that a contextual query will be fired to our system, and how the query will be executed is that, so there are set of entities and their values, which is coming as a query. And there are things, there are documents like nodes and guides which are in our system. So as Gaurav explained that we have a template which works for both contextual query and text-based query. So now it depends on that what phone you have ordered, whether we have data related to that phone or not, or whether we can deduce from the phone. Let's say that you ordered a Moto G4, okay, which is not there in our system, but if it has Android, right? So we can maybe return you some Android related articles, sorry, troubleshooting guides. So this is how it is. But of course, all the issues cannot be solved. So there will be a topmost node, which will be the product node. So from there, they will start like issues. So your phone is restarting. So there will be a restart issue type, maybe. Or sometimes it doesn't fit, but in most of the cases, we are able to. Yeah. Correct. Mm-hmm. Okay. Subhadeep, related to FAQ.
Yeah, so this concerns the FAQ part. Are you saying that? Yeah, the customer. Yeah, please. Okay. Uh-huh. Yeah. Okay. Uh-huh. Uh-huh. Oh, you're saying that how do you incorporate new data into the system? So yeah, that part we missed. Good question. So the thing is that we do have a content team. We do have products which are built around that. So what we do is we figure out a set of null queries which did not meet a level of relevance. So we have certain systems which allow us to compute the relevance on these queries. So from that, we have a job which like mines this data out and sends out a report saying that for these things, we do not have sufficient data. And that is still manually analyzed. I'll not go into that depth that we are doing it technically. So it's manually analyzed and people figure out what is needed, right? So,
Okay.
yeah, please go ahead.
You already have a set of issues in mind.
Yeah.
Yeah. So let's say, can you train on creating new issues? Because the support vector machine is basically
Yes.
supervised.
Yes, it is.
So what if the customer query start coming about new issues? How do you
Okay.
incorporate that?
Yeah, so the thing is, the current work does not answer that. So we do have a fixed business-defined set of issues. What we are doing here is mapping the documents to the set of issues. So that might be hierarchical. So we are still working on the hierarchical part, as in a hierarchical classification. So you have return approval. Below that, you have a return status inquiry. So yeah, please. Mm-hmm. Yeah. Mm-hmm. Yeah, so so one of the key things in this talk is that we did not have enough data. So as Mukesh mentioned, right? So what you need to do is leverage whatever you have to build out a model which is as good enough as possible. So a lot of our time was actually spent in refining. So there were phases where we sat down in a meeting room, figured out that this is not working, let's fix this. So most of the, I think, practical machine learning comes out as that you see a problem, you fix that. So does that answer the question? Yeah, sure. Yeah, please go.
Yeah.
A follow-up question on what
Okay.
Guy asked.
Yeah.
So you say the issues are a hard-coded list of issues which
Correct.
the business has already identified.
Yes.
So now the challenge lies in mapping the customer's query to one of the issues,
Correct.
plus mapping a relevant document to
Correct.
the issue,
Yes.
right?
Yes.
So the first part sounds difficult, but the second part should be easy, right? If your HTML help pages or the knowledge bases already have structured things, why can't I go ahead and map it with my fixed set of issues?
Yeah, so let's talk about that. Let's say that the issue is delivery related, right? So there is a document which talks about delivery. So that's a textual document, right? So what is defined in the entity space, as Mukesh mentioned, is not issues. So you have stuff like brand, followed by something like shipment partner, things like that. So that allows us to do a contextual query well. But when it comes to issues that somebody has chosen an option on IVR saying that my return is stuck, so that allows us to retrieve certain, so this is just another signal. You can think of it this way, that this is another input signal to the system. One of the many signals is entity, which we gather from the order context, meaning that we know that this is the product, right? That's like a dang string match, right? But there is a hidden, so you see that a issue is a hidden latent structure inside a document, right? You just can't say just by reading that this is a news article. I mean, for humans it might be apparent, but depending on the text you have, it might not be so simple. Yeah, please.
It from news articles is a totally different thing, but what I believe is the set of knowledge base which you are putting up to the customer care agents need to be much more structured than a news article.
So the thing is, a knowledge base is not just about entities, it's also about, let me give you an example. Yeah, that will be better. So let's say that there is a document which says that there is a delivery hub problem in one of our hubs, due to which all the products which were going to go out of this hub will be delayed by another day, right? So what do you do about that? So you have to figure out that this is the hub this document talks about, get that hub, figure out that which products were supposed to be shipped from that hub, and correspondingly we get the article. So does that answer the question?
Yeah. Okay, one last question.
Please, yeah.
It's a vocabulary of words which can be present in the document.
No, document can contain anything.
Yeah, so in that case you are using DF. Also I have seen you are using engrams. So if I enter a word when I'm searching for something which is not present in your set, in any of your document, but which is similar in the meaning. So how are you handling that semantic thing? Are you maintaining any graph?
That's a good question. So you are talking about out of vocab. Yeah, please.
Straightforward, like the same, you are tokenizing the query and you are assigning the score, so similar like scores to the tokens, and then you are relating to the documents. So what I want to say is like each token is have some association with the tokens with which it is being presented, right? So sentiments behind the token. So the score should be different for the same token in different query.
When you mean by sentiment, what does that exactly mean? Meaning that. Okay. Okay.
May not be strong enough, like suppose there are two queries,
Yeah.
and the word is present in both the queries.
Yeah.
But the effect of the word
Yeah.
in the query 1 and query 2 will be different.
Yeah. So to answer that, I got the question. Yeah, please.
Score for that token, score will be same for both the queries, right?
Yes.
Yeah, because that is dependent on the documents which.
Yeah, let me answer that. I got your question. So you have an embedding model. So embedding model, think of it as a space in which vectors are represented. So if you have a vector for cache and you have a vector for delivery, they will be pretty far apart. So that allows us to compute the distance between them. So if you have a lot of things which are together, that means that they are a semantically related stuff. And to answer your question that how do we treat out of vocabulary words, to be very honest, we don't currently, but we do have a plan for doing that. But that requires an external data source wherein you can compute that this word we have not seen, but this looks similar to that. So instead augment with this. So if you want to catch up, we can catch up offline and I'll tell you what techniques are required.
Thank you, Subhadeep.
thanks a lot.
Actually, guys, we have to wrap up. Lunch is next, so you can catch any of them outside for a conversation. Before that, you have to choose the best question, and that person gets a mug.
Sorry, all questions were really good. So it's very difficult to choose.
You have to choose one person.
Okay. So let's go ahead with the first question. Okay, what's your name? Yeah,
Please
Harsh.
join us here.
Please.
And we have Subin in the Audi. He's going to take a mandatory selfie in this auditorium or at all the conversations. So if you all can please face that way.
Okay.
We have some goodies for the speakers as well.